Hello, everybody, and welcome to today's vOLTHA TST. Thanks for joining. As usual, the call is public and recorded and will be shared live on YouTube. So please be mindful of the comments you make and the information you share. Um, so today's topics mostly revolve on the updates on the first elements that on the last elements that we did these last weeks. The first up, I would like to get an update from David and Ken on the status of the gRPC swap. So Ken, David, what are your updates?
Yeah, sure. First, I think we need to ban David from doing any testing because he's seeing too many errors. Just kidding. In terms of fixes, there's a bunch of fixes that went in last week. There were some issues with when the ONU adapter restarted, and the course restarted. Now we're seeing errors, not errors that are specific to only one scenario or one container having a problem. It's really a combination of things happening. For example, there was an issue where a core restarted and the test was passing correctly, and then after that an ONU adapter restarted, and then everything looks okay, but there was some incorrect assignment that was done in the core that was causing the subsequent test to fail. So there has been fixes in that area. There was one on the core restart itself. One big one was on the core restart. So I changed the processing there to address the specific case of core restart. In my environment, works well. On the hardware test, seems to work well. David seems to have some issues there, so it's something that needs to look at in that area. But one general thing that I'm seeing a little bit more now is in my environment, a lot of well, pretty much that all the tests are passing, but that's not the case in all environments. Meaning there's a high chance that we are uncovering a lot of risk conditions, and those risk conditions there's two cases. In general, there are two cases. One was is gRPC is faster, so that is bringing in a little bit more race condition. And the other one, there was some things that were hidden by the use of Kafka, and that was causing issues before, but they were kind of hidden issues. For instance, when a container was talking over Kafka, pretty much it was sending a message to the on Kafka bus and then wait for a response. But if nobody is picking up that message from Kafka, that caller will just time out, but that message will remain on Kafka. For example, if you have an ONU sending a message a proxy message to an OLT adapter, if the OLT adapter is not ready, the ONU will just keep sending message, timeout, keep sending message. And when the OLT adapter comes up, it's not going to read all the previous messages. It's just going to read what's new, because that's how the Kafka interface was configured. So all the previous messages are being ignored. So the queue on the Kafka was building up, but we wanted to it was not causing any issues, but eventually that will have caused issues. So there are things like that were kind of hidden before, but now we are uncovering because now it's a direct connection. So if when a message from the ONU goes to the OLT, if it's not there, it's a failure. It's a direct failure. So we are uncovering a lot of issues, and I'm sure we are going to uncover a lot of more issues by having this, in a way, things needs to be a little bit more synchronized than what they used to be, because Kafka was offering that buffer. But all in all, there's a little bit more tests that are passing in most environments. There was a case last Friday when we run the last test. There was an ONU reboot failure, and Girish mentioned that that test has been inconsistent in that environment. So either a fix needs to go in, or we'll need to restart the test again and see if it passes or not. So that's where we are in terms of testing.
I did just have the failure scenario test pass in my environment, all those. I haven't run all 4 tests I normally run, but the standard BBC failure scenario test just passed. One big difference in my environment is I'm not using port forwarding for vOLTHA connection right now because I've modified the system tests to contact the pod directly.
But
so,
I did. So I had a question on this. I was trying to follow the discussion on the channel that we are having. How come that makes a difference? That should be just northbound of the core.
Yeah. One of the issues is when the core restarts, the pod restarts, and you're using port forwarding into the kind cluster. I haven't validated if it's into a physical cluster or not. Essentially, Kubernetes loses its mind, but port forwarding loses its mind. The only way to be able to get the port forwarding working again is to restart the port forwards. And I've noticed this behavior in kind where if you're port forwarding to a service, the implementation of the service goes down, Kubernetes can no longer forward to that service, even if the new implementation comes up. So when instead you use the vOLTHA pod that other tests have already installed into the environment and go right to it, you don't have that issue. That makes sense?
Yeah, it makes sense. I've seen the same, but I'm just using the ingress support to avoid that issue. Because it seems that the ingress is easily support service restart.
Yeah, the ingress support is better at it. The only other thing that right now we're inconsistent. Some of the tests use port forwarding. Some of the tests use the internal pod. The benefit of using ingress is, of course, you're kind of testing the full path that someone would be using from in an operational environment. I mean, you're coming into the cluster, and so that's good. The con of using the ingress or port forwarding is you have to watch for port overlap on your local host and manage that. What I'd like to see in terms of the test is we do it consistently. I'm perfectly happy for everything to go to ingress controller, but I think we should be doing that everywhere. Or if we decide to use the internal pod, we should be doing that everywhere. We shouldn't, I think, be doing both.
Yeah, I agree. I think the main reason to use the internal pod was to reach over to Kafka and check the alarms, because it's not trivial to expose Kafka via port forward or node ports or ingress.
Yes.
If I recall correctly, that's why we were using the internal pod in some of the tests.
Yes.
And I think we actually used that only in the tests that cover the alarms as well.
Yeah, precisely. The alarms test should be, and if somewhere else we find this, we should fix it. The alarm test should be the only test where we use the vOLTHA in a pod, and for the reasons that Theo pointed out.
Understood those reasons, but in reality, in an operational environment, we've got to solve this problem: how to expose that external to the cluster. So our test should reflect an operational environment, I think, which means if we expect people to be reaching from outside the cluster to get this information, we need to find a way to enable it.
Do we really expect someone from outside the cluster to read from Kafka, or a different component in the same cluster? Because that was kind
that
of
API is exposed via gRPC and vOLTHA, right? Or vOLTHA actually. So
yeah, but we don't really expect people to use vOLTHA to react to events. We expect people to have some kind of software components that listen to Kafka and reacts to the alarm, binding to the OSS or whatever layer they have on top.
I think if vOLTHA exists, people are going to use it. And that includes some of the alarm stuff. If we do not expect people to use vOLTHA to look at the alarms, it probably shouldn't be in the command category or the command catalog of vOLTHA.
So I'm not saying we don't expect people to ever use vOLTHA to look at the alarms, but I kind of expect that to be kind of a human intervention scenario, while the main use of alarms, I guess, is to have some kind of listener on Kafka so that the alarms can be bubbled up in the support system of the operator.
I would agree with that. But if we do expect a human to use it, then we need to find a way to enable that from outside the cluster.
Yeah, I see your point, but if it's really a debugging tool, I don't see a huge issue having someone spin up a vOLTHA container in the cluster to get around exposing Kafka outside.
I agree.
But I'm open to different point of views.
I agree with Theo here. The way we have done it is just because I do not expect the Kafka to be reached by anybody outside the cluster in a production environment. And given that we've always said that Kafka and etcd are mainly an operator decision to have, and with this we could also completely avoid Kafka if an operator just doesn't want it. I believe this should not be of our concern at the moment, or at least it's not of my highest priority.
Okay. No, I agree. It's not a high priority. Do we want to at least then enable Ingress controller for all the tests, or put that somewhere on the priority list as opposed to the port forward stuff?
Yes.
Yes, we want it somewhere in the priority list. I don't know where. The scale test is actually already using the Ingress controller. It has been postponed when we refactor the pipelines because we are internally working to set up a DHCP server for the entire lab in Menlo. And that will tie pretty closely with the Ingress management, if that makes sense.
Okay. Just probably needs to be put on the queue somewhere.
Yep. So David, just as my understanding, so what you're saying is that with vOLTHA and port forwarding, even with restarting, it doesn't pass, or it does?
So I just got a second pass with the core restart using vOLTHA pod. So things seem to be going okay in my environment, which is good. I did talk to Ken a little bit about the core restart patch, and I chatted about that this morning, and I did see Ken's response as well. So there is that kind of, the core essentially tries to recognize when it restarts, and when it does, it will not accept requests from the OpenFlow agent until it thinks it has had all its adapters reattached or re-registered, and at which point then it'll open northbound communication. I've talked to Ken about this too. My concern with that is there's a heuristic there, a special case. It says, okay, core, I think I'm restarting, and I think I know how many adapters should attach to me. And it uses that number. If it's wrong, in other words, it doesn't know how many, or all the adapters aren't going to come back up or don't reattach, then the core will not start communicating the OpenFlow agent again. The number of adapters in our system is not a static value. It's not a set value. It is meant to be dynamic in terms of however many you've started, when you've started them. I'm a little worried, concerned that in the restart case, we've essentially said we expect the same number to be there after we restart as was before we restart. It just means the core knows something that I don't think it should know, or it's not meant, from the design perspective, it's not meant to know. And it works in this case, and it'll probably work 99% of the time, but
a few things about that, David. It's currently we don't have a process of registering or deregistering, mostly deregistering an adapter. So when the core restarts, first the core knows it's restarted, like it's coming up.
Yeah.
It will just take a peek in the KV store and see what are the adapters that are there, and the adapters that are the one that have been registered. So at that point, it will come up and try to connect to those adapters. Yes, there is that scenario where an adapter is no longer needed. It's permanently down, and that will prevent the northbound interface to be available. So that's something that we need to find a way to address that. But the main reason why I made the northbound available only after it's connected to the existing adapters that have previously registered to it, it's really during that time, the core doesn't have any flows in it because it got restarted. So the northbound interface, ONOS, is going to send a bunch of flows. So if we have tons of devices out there, all those flows are coming in, and we're going to decompose them first, and then figure out where to send them. And now when we are trying to send them, some will go to the ONU device and some will go to the vOLTHA adapter. And during that time, what happened is one of those adapters, both of them may be down, may not be available, means the connection, the gRPC connection has not been established yet between the core and the adapters, or one of them may be up. So if one of them is up, so the flow is being sent to them and may be successfully added, but when it's sent to the other adapter, that one fails. So when in that specific scenario, the core, what it will do, it says, okay, let me delete that because there's a failure. And then it will delete everything. And then ONOS, on the other hand, will say, oh, you don't have that flow. Let me send back that flow to you. So that process of repeat adding, failure, deleting, until everything comes back up, what I've noticed was causing a lot of problems, especially on the ONU adapter. Where after a while you just say what's happening? There's too much delete happening here. Like I added it and then you want to delete it. So really the change that was put in is really to prevent that from happening. That specific scenario, because that was causing a lot of issues downstream. And yes, it's not perfect in the sense of we could have an adapter that no longer comes back up. But once we have established a pod, we say we need to have adapter A, B, and C in place, then I will expect we would always need them to be up and running. And if any one of them is not available, then the entire pod should not be available for now, and until we actually have this deregistration process of an adapter.
Yeah, I understand that. It's just, that means the core is assuming something that, from a design perspective, it wasn't meant to originally assume.
So I haven't seen the implementation yet, so it may be already this way, but can it be implemented in a way that when we receive a flow, the flow is tied to a logical device, and we should know which type of logical device that is, and so we should be able to say, okay, do we have enough adapters to handle this request?
Also,
That's kind of the same thing that happens when we do the enable call, that if the adapter is not registered, the core says, nope, you cannot enable it.
Yeah,
Also-
that's another fix that an additional fix that I'm putting in, but that's not done at the OpenFlow level. Well, not at the how we call it, the logical agent. It's being done at just the device agent level, because in order to know, we need to know after we decompose that flow, what are the adapters that those flows are going to go to, because you can have an OLT adapter available, but the ONU adapter is not available. So that fix will go at a level a little bit further down to make that decision. But nonetheless, that flow decomposition will still need to happen in order to know where they should go.
Also, another
Yeah, that still happens, but it's much faster than sending the request to the adapter and failing it and then removing it. It will still prevent that loop.
Yeah, for sure. That's why I'm saying, like, this is an additional fix that needs to go with the change in the core restart scenario.
So another question, Ken, on the concern that David had about the core doing something that is not intended to. Can we have it dynamic in the sense that whenever an adapter registers to the core, it gets put into a list, and then whenever the core goes down, it comes back, reads that list from a TCD, and says, "Sure, I have all of these. Oops, I don't." So it makes the decision based on a pre-registered list of adapters.
Well, this is what happened today.
Yeah.
Okay, then where's the issue?
The point is, the core is assuming it knows what adapters are going to be there, and it knows that once these adapters are registered, it is in a complete state or a operational state, and that's the patch Ken wrote. My argument is the core should never. The core was not designed to understand how many adapters it was talking to, and quote unquote know that.
But it was designed to accept registrations of the adapters.
Yes, but when it restarts, it's not saying, "Oh, I'm not going to consider myself up until adapters that were registered when I went down are back," because it may be that those never come back in a 1% case or a low percent case.
If they don't come back and they were still registered to the core, sure. So we're talking about that 1% where the adapter wanted to unregister and it couldn't.
No, we're talking about the case where the core restarted, and when the core restarts, it's assuming that these things are going to reattach to it.
Yes.
It assumes it knows that there are 3 adapters out there or 4 adapters out there, and until those 4 come back, I'm not going to accept northbound calls.
Yes, but there are
there are
2 reasons why they couldn't come back. One, they wanted to come back, but they couldn't re-register with the core, and that should be treated as a system failure. B, they didn't want to come back because they wanted to unregister and disappear. So A, we treat it as a system failure, which is correct. We just let the system in a state where it couldn't handle any calls because we expected something that didn't come back. B, what we could do is we could put in a retry mechanism in the adapters to continue to register if they expect the core to be there. So at some point, they re-register with the core and then say, oops, I need to go away.
Andrea, they are already doing that.
So
I think
my point being is that
so if I understood correctly, the issue is that we have, let's make an example, the OpenVOLTHA adapter and the Atran adapter. And while the core restarts, we decide that we don't have any Atran device in the system, so we remove the Atran device, the Atran adapter. So the core comes back, it finds only one adapter, and it will never open the OF agent connection because it's missing one of the adapters that were there. Is that the issue we are concerned about, right?
That is a symptom of the issue, but yeah, the real issue is we're now the core was the design point of the core was never to say I know how many adapters are attached to me, and it was meant to be adaptive and deal with adapters coming in and out. So we've changed from the core, if adapter's there, it'll call it, to we have a set of adapters that the core expects to be there in a restart case at least, and it will not function until that set is up. Yes, yeah, the example you gave is an example of what could happen here. And I agree, it's a low percentage case. The point is, my point really is we're changing the design criteria, and if we choose to do so, that's fine. But on
the other side, if we change the thing so that for every flow that the core receives checks, do I have the adapters to handle this request? And if yes, I'm going to proceed. Otherwise, I'm going to fail it in the core. Then we're not changing the design because it's still a fluid list of adapters that can change at any time depending on the flows that arrives. And there is no problem with having a different list of available adapters compared to when the core was up.
The issue I think Ken pointed out, and correct me if I'm wrong, Ken, is while that is affixed here or would solve this issue, the problem is when the core restarts and before the adapters are re-registered, every flow that comes from northbound will have to be decomposed and sent to the two adapters, one of which may be up, and it becomes a lot of processing for nothing.
But it doesn't have to be sent, because if we know that the adapter is not there, is not ready, we don't send it to any of them.
Yeah,
it's like an hybrid approach of the two.
That's the other fix that I'm putting in, but you still have this scenario of a core restart where you're getting a huge amount of flow being decomposed for no reason, right? Uselessly, because it's those flows will not go anywhere.
Do we know if that impacts performance at all, or what the impact of that is?
Well, I've not run tests against that, because we are running like maybe like one ONU, one OLT, we're already seeing problems. I suspect once we have like thousands of ONUs, we will have some performance issues until those connections are up. But one thing that I have to say, like, we are not really changing the design. Yeah, if we go to the corner case, yes, we are. But in a sense of what the core is doing, it's looking at, on the restart, it's looking at what all the adapters have previously registered to it. So those adapters have registered. So it needs to connect to the registered one before declaring that this pod is up and running to accept northbound calls. One thing that we don't have today is this deregistration of an adapter. And another way to to look at this is currently we have a adapter registered when it goes down. We could also have scenarios where potentially on the core restart, the core queries the adapters that he has in place to see if they're still available or not. That's all. Now with gRPC, what we could also do, if an adapter detect that the core is no longer available, once it's available, it will send a registration message to the core. That is also possible with what we have today.
I do want to reiterate, I understand this is a very low percentage case that we hit anything, right? Because it's a very low percentage case that during the core restart, someone's actually going to delete one of the adapters, or it would be a very odd failure case. I just, again, it is something different, and different is something that sticks out to me.
Mm-hmm. Yeah, I understand. Like in any case, I was going to do the other fix.
Yeah, I understand. Yeah.
So I'll put that in, and then we can run. If we find that it doesn't have a real performance impact, and it's only the core in any case doing all those decompositions, then maybe we'll just use that scenario only instead of doing the other heuristic approach. So it's something.
And to be yeah, and to be fair, it's a perfectly reasonable design choice. We want to switch something to say, look, we're going to somehow register adapters to the core, and once they're registered, until they're deregistered, it is assumed that those adapters will exist and be connected. And when they're not, the core will not accept northbound traffic. That's a perfectly good design decision if we want to make it a perfectly valid design decision. But if we do that, I think we need to be very clear that we're doing that.
Yeah, I agree.
Yeah, makes sense. Just on the scale impact, on the performance impact, that's something kind of tricky to measure. First of all, because we are not testing restart at scale so far, so we don't have any number on how the system is behaving today. And that will have to happen while we bring up the devices. Because if we wait for everything to be ready and then restart the system, there is really not much that is going on. So we'll have to go back and check how it is working today, if it is working, and then check the difference.
You mean like on the core restart with Kafka today?
Yeah, we only ran that during the functional test with one OLT, one NU. I don't think we ever tried, or for sure we haven't ever measured what happens when we restart the core with 1,000 devices on it.
Yeah, in the case of the Kafka scenario, that won't I don't see that as being an issue because when you restart the core and the core comes back up, when flows are coming in, the core literally doesn't care whether the adapters are present or not, or up and running. What the core will do, just send all those messages onto Kafka. And at that moment, like especially in the test case that we have, the OLT and ONU adapter, they are still running. So they will still be able to get those messages and run them. So I don't see that will be an issue with the Kafka, by having Kafka there. In our scenario, we don't have this buffer in between the core and the adapters with gRPC. So that's why we need the connection to be up. That's the difference.
Yeah, and so a valid test will actually be restart the core and restart at least one of the adapters, basically at the same time, so that the adapter is not yet there when the core starts sending messages to it, regardless of whether it's Kafka or gRPC.
Well, that would be a different test, right? Because here you're forcing the adapter to be down. In the scenario of gRPC only, the adapter is up. It's just a connection to that adapter that is down.
Oh, okay, yeah, I see.
But it's a valid test to see, like that. Do we have any performance issues even with Kafka? I suspect we won't, but never know.
Is there a way we can sever the gRPC connection to actually try this scenario instead of bringing the whole adapter down?
Well, we don't need the test will be restart the core at scale and see what happens. How long does it take before the flows are back in added state? Because when we restart the core, the flows should go back to pending add, and then they'll take some time to go back to added. So that's a test we can add to the scale. It shouldn't be too hard. All I'm saying is just we don't have it right now.
Yes. Okay. So let's switch topics. Let's make some progress on this. If you're confident with all the tests passing, David, we could possibly try it out more on hardware at scale, do some things like that.
Yeah, at this point, I'm getting pretty good results, so I'm probably need to move to. I would agree that we need to move it to the next stage.
Yeah, Girish already running it on hardware. There's just was one issue on the hardware that was a little bit inconsistent. Which has nothing to do with the gRPC changes, but it needs to be looked at, and that's I think Girish was looking at that.
Yeah, it's the OAT reboot issue. There are some problems. Andrea, we are also seeing some inconsistencies with the Kafka transport. I had some questions for Ken. Yeah, probably after this meeting, I'll reach out to him.
Yeah, sure.
Yeah, I can also run it a few times at scale today and tomorrow.
And we should probably set up one job with the 50 tests with all those images.
Sounds good. Yeah, I can do that.
What are those 50 tests that you're mentioning? Is it the regular test that we run for, or is it something else?
No, with BBSim we run those.
So is the full suite of the functional test plus the error scenario plus the failure scenario?
Yes.
Okay. That's the one that Girish is running, I believe.
No, on hardware we run a lot less tests.
Okay.
Well, I think it's pretty similar because those 50 tests contain the alarm test
yes.
that I don't think will be affected by gRPC, and they are like 20. So
yes,
yeah, there's okay, because the number of tests I see, it's like 29 tests. I think the one that Girish is running.
Yep.
And this one is 50. Okay.
Yeah, this one includes all the alarm suite. So it's alarms here, failure scenarios, error scenarios after this, and possibly a couple more that we don't run on hardware, but just very minimal. Maybe we could also set one up for one of the OpenONU Go jobs that does some specific OpenONU Go tests as well. Some maybe this one.
Yeah, that, I mean, it should be fairly easy to set them up because all the tests now accept a parameter to use a different patch of the Helm chart, and
Yes.
you can customize the images. So it's just a matter of creating the job.
Yep.
And by the way, I don't see how the alarm test can be affected by the migration of gRPC because it's the component directly sending stuff over Kafka, and that has not changed. There's no different timing with the components, I guess.
No, but it's easier because this job is already set up, as you said. Just
Oh yeah.
Yeah.
this one, just
Yeah. No, not arguing not to run them. Just saying that I will be surprised if they break.
Oh yeah, absolutely. Okay.
And I generally get surprised when I say this kind of thing. So maybe I shouldn't have said anything.
You jinx it.
Now, Theo, we know where you live, you know. Okay, so next up is the vOLTHA app rewrite. I can provide a little bit of an update. In the past few days, starting from the great work that Theo has done, we've collaborated a lot and done a few more extensions to the rewritten app to be fully compliant. Extended it to have all the APIs for the C tag and S tag, that specific service that were there. Then there were a few minor elements that were commented by myself in my review, and I addressed those as well. Long story short, I'm working with Theo to have this ready. I think we are fairly close. I'm observing one small issue in Turk Telecom workflow. I'm seeing 2 rules more than what we should have, so that needs to be investigated. But we're fairly close. And the app design is much simpler, straightforward, and better. Also, in error scenario cases, for example, we're actually looking at the installation of the flow successfully and not just the success of the flow objective, because the flow objective success is just given by the pipeliner, while the flow is actually the open flow messages success. So that's a really good improvement, for example. There are many other things. We're almost there. Should be pretty soon. Theo, anything to add?
No, not really. So you pushed quite a bit of code between yesterday and today.
Yes.
I'll look at the code today and then merge it.
Yeah.
But yeah, I agree. We should be close. I think we are almost at the point in which we can start testing it on hardware and at scale.
Yeah, as I said, there's a few minor things that on different workflows that I see as an issue, but we can talk about them separately offline. If anybody is interested, this is the code, and it works as a drop-in for existing applications. So you can just uninstall the existing version of the vOLTHA, build this one, install this one, and you should be good to go. Maybe Theo, we can add a part of the README if anybody wants to try it out.
Yeah, I'll add it today.
Okay, awesome, perfect. Okay. Any questions on this one? Okay, then last topic I have is the MPLS support. Amit, any update with this? This is Berlin discotheque.
I didn't know Amit was in a
What-
discotheque.
one might ask how you know.
I've spent 6 months there, David,
Okay.
With Amit. In the discotheque.
with Amit and Bjorn and the rest of the folks. So I've partied pretty well.
Can you hear us now?
Yes, we can.
Okay. Yeah. So nothing new to add on the MPLS topic. I think we discussed last time, and that's where we are.
Okay. Okay. Is there any help that you need? Any clarification that needs to be done on anything?
No, I think we are okay for now. As I spoke last time, the next thing is to schedule the changes that need to be done on ONOS for the extensions, as well as on the app to provision the flow rules with MPLS board. So those are the next two things that need to get that needs to be taken up.
Okay. If I can suggest, I would go first for the extensions and then with the app change.
Yeah.
Okay.
Yeah, by the way, the MPLS changes are into the gRPC changes as well. So they are already like being rule-based.
Cool, that's good, yeah.
Okay.
Do you want to go on the ONOS topic as well? Or?
Right. Okay. Most likely, I was talking with Amit, most likely with this, there will be obviously a new release of vOLTHA ONOS, but also I need to do a minor release of ONOS 2.5 because of a bug we fixed, and that is not included in 2.5.2, which is the base for vOLTHA ONOS for 2.8. So I'll try and do that. I was waiting to see if the app rewrite actually uncovered any issue in ONOS, but it seems not. So any deficiency in ONOS, it seems not. So I think we should be pretty good on the ONOS front to have a release. Any questions or comments?
Does the new release includes the change in the meter ID deprecation and the meter cell ID implementation?
It will, yes. We will need to test that. I've already done some testing. So I know that as of today, without the latest changes from the guys at the SD Fabric team, it works. But there is a still in-flight change from Pierre that I will need to test. Effectively, what I will do is I will create a vOLTHA ONOS image with whenever that is merged based on the latest 2.5 image from ONOS, and I'll just run it through the whole set of tests. The one thing that I wanted to mention is that we are now back publishing ONOS latest images on master 2.5 and 2.6. That was skipped for a month or so, given the changes that the auto build feature from Docker, they disabled that and we were using it for ONOS. So I just put in a Jenkins job in place.
Andrea,
To say something?
yeah, a question about pod support. I mean, we're writing a document about voice support in vOLTHA
Yes.
for plain old telephony service. I'm wondering if we have any hardware to test it. I mean, ONUs with pod support. You know.
I think the ONUs that we have might have a UNI port. I'll have to go back and check.
Okay.
But I have never tested. I mean, what are the external devices that we would need to test this? I mean, I have never done this.
That is a very good question. I wouldn't even know. I mean, for example, at my place, I do have an ONU that supports VoIP, and the guy that installed it had to do some very specific. Well, they had to connect a phone and dial in some numbers so that upstream they knew what that was available. So I guess we would have to have a procedure like that for testing, and also. How can really this be tested, Mahir? Meaning, how can we send VoIP traffic to that port?
Yes, this is a part of the first we can at least test that the ONU has the port and it is discovered, and it's the MEs in the ONU are created accordingly, and this ONU is configured accordingly. So this is the first step. We can do that by testing. This is, I mean, not. It's easy, but as you said, traffic test is hard. I don't know. We have to think on it because somebody need to take the VoIP phone off and dial some, as you said, numbers. And I don't know how we can do this actually. We should, I mean, think on that. But at least we, as I said, we need to have an ONU to discover the hotspot correctly and configure it.
I think the Alpha and the Iskratel ONUs that we have the ports uniport. As far as I remember, I haven't been to lab in some time now. But
I'm going to the lab today, so I can check.
Okay, thanks to you. But I'm just throwing in some jargon here. I mean, I'm not sure. So if the ports uniport, I mean, if you have a ports unit to RJ45 converter and we hook that up to some server and start sending in some traffic, the entire VoLTHA stack, the switches and OLTs that we use are transparent to, any VoIP protocol. So as long as, BNG is able to see some traffic on the other end, I think that's good enough to start.
Actually, after you configure this port, I mean, you connect the VoIP phone to that, and after you correctly configure it, you expect the VoIP phone to send SIP messages, which are, I mean, IP packages. So for vOLTHA perspective, there are still some IP packages going through the OLT towards DNG. So.
Yeah, so that's what I was saying. So the SIP protocol, all these things are transparent to the data path.
Yes,
so,
yes. Only, I mean, we need to make some configurations to ONUs via ONU adapter. We have to create SIP MEs. We have to define the SIP proxy address. We have to push the user's username, password, etc. to the device. So there are some service-specific MEs and subscriber-specific MEs should be created in ONU itself. That's all. Other than that, remaining are the SIP packages, data packages going through the OLT.
The other thing is that, if I'm not mistaken, some of the initial configuration that is done at the start with the phone and the numbers and all of that could possibly be done once, because it should be persisted after reboot, but I'm not 100% sure.
But is that a configuration for vOLTHA or for something upstream? Because if it's for something upstream, we don't really need to test it with vOLTHA, because those are, as Girish said, transparent packets that will go through the stack.
Maybe for the ONU as well, I don't know. Because especially if it's a uniport on an existing, that's like an Ethernet, normal Ethernet uniport, on which you plug also the cable for the phone, it might be that you need to configure that port to be enabled, or something like that.
Yeah, it seems a little weird that you configure the port from the port itself.
I couldn't get the point, guys, sorry.
Fine.
What do you mean configuring the ports on ports?
No, that what these numbers that Andrea was talking about, I think they are basically sending the steep equivalent of DHCP discover to something upstream. I don't think they are configuring anything on the device.
I'm not sure. Maybe, possibly, hopefully.
Anyway, I can
I'm not
take a
sure.
look into the OMCI specs to see what BB team will need to send to report one of those uni, and that could be a start.
Okay, we initiated a document, but it's just very draft now. I can put something, I mean, to the document and clear some parts of it and open it to you, at least till now, and you can see at least the OMCMEs that should be created. That's it. I mean, maybe may help you.
The other good news is that some of those MEs, I know Chip is putting them into OMCI LibGo. He has a presentation on the status of OMCI LibGo tomorrow at the Open a New Go call. So that's present as well.
Özge is actively talking with Chip, and Özge also trying to, I mean, prepare a POC in NetCL lab for this, and try to see if these MEs are working or not. So yeah, they're in touch.
Good. Okay, guys, we are a couple of minutes over. So thanks for joining and thanks for everything. Let's keep up the good work. We'll set up the tests for the gRPC nightly, so that's good, and we'll keep everybody posted on everything else. Mahir, if you can send the document, I'll add it to the agenda for next time.
Okay. It may not be finished until the next week to discuss all, but I will send the document, a draft one. Okay.
Okay, thanks. Okay, thanks everybody. Let's talk again next week. Cheers. Bye-bye.
Thanks, guys.
Thanks. Bye.
Thank you. Bye-bye.